Go through it once we are there, and then after that timing test. So we'll start inshallah. Bismillah ar-Rahman ar-Rahim. I have here a protection relay. It's differential protection with backup distance and backup overcurrent. This is 7SD5. It's a Siemens, so the make is Siemens. The module number is 7D5, and it's basically a differential protection, but we have a backup distance protection. Whenever the differential is not working, we can enable the distance. We have other functions. These relays are numerical relays and have different functions. It's one relay contains differential, distance, overcurrent, maybe either voltage or current protection. It's multifunction. We can enable whatever we want, and we'll go through the configuration of the relay. Now, this is a very reliable device. It comes usually with warranty for like 10 years, so it's almost free of maintenance. But what we need to make sure is the setting inside the relay. Now, the second thing here, we have the Omicron device. It's one of the best testing kits in the market. It's a secondary injection, because what we are testing is secondary device. We're not in the real system of high voltage, neither 11 or 33. This is all the voltage here we have is like 110 voltage DC, and the current for maximum during fault it goes like 20 ampere. So this is secondary testing kit, because it cannot inject very high voltage or high current. Normally it goes up to 10 ampere, and the voltage goes up to 220 almost. So the Omicron is a testing device, and it's named CMC356. It's famous. Once you are in the market, you will get to know it. Both buttons take time. The screen is very small, so usually we will use the software. We have another software to control the testing kit. Now, the connection. I connected the testing kit to the relay. First connection is to only power the relay. This is auxiliary supply, only 110 voltage to operate the relay. Usually relays will operate on either 110 voltage DC, or even nowadays except ACs, or in all substation we have 30 voltage DC. We call it auxiliary supply of the substation. It's only used for the control circuit and to operate the relay, to make it on only. Now, the second connection, I have a feedback. We have two types of it. There is multi, but at least now we have two types. We have one, the trip signal, assuming if the relay send trip signal, I'll receive it in the testing kit. In real life, it will go to the circuit breaker. I have a pickup. Usually the pickup, whenever the relay starts counting, whether to work or not, but it takes time. So the pickup usually will use it only to know whether the relay is working properly or not, or sensitive enough or not. So I have two types of feedback. One type of the test will have to know which output configured here to know this is trip and this is start. I'll go through it again. The last one is the injection. I have here 3 sets of current and 3 sets of voltage. ABC or yellow, red, yellow, blue. It goes in the test kit. I could have connected it directly to the relay, but it will take time, and for the simplicity we use what we call a test block. And the one which we inserted here is a test block. At the end of this test, maybe I'll remove it out just to show you how it's working. So in the substation, I'll not go and work with the connection in the back side of the relay. I always work in the test block. So we'll start, inshallah. Up to now, you have any questions, please ask me anytime. We'll go through it now.
ايش تقصد انك ما تروح على الكونكشن اللي خلف الراديو؟
Again?
الكونكشن اللي خلف الراديو بس تشتغل عليه؟
I have already connected, but I'll show you through the manual.
So this is the manual of the relay. Each time you have to go to the next.
The relay is 7 SD5. Now the rest of ordering code will decide the auxiliary supply and the rest of functions available on the relay. Now I wanted to show you the connection in the back side. Give me 1 second. We are here. We have 4 sets of the current, so it's red, yellow, blue, and then neutral. Now in the back side of the relay I could read Q1, Q2. It's usually 1 Q, then I have to know this card is Q. Once I want to connect the current, I have to locate the Q1, Q2, Q3, Q4, Q5, Q6 and go through it. This is the current injection. Usually the current comes from the CT in the substation. The BT connection is in the R card. R card 15, 17, whatever. Now, before this, I have to locate the auxiliary supply to just make the relay on. So usually in K card, and it is.
One question on Muhammad. What's the input of U4?
Come again.
And, I4 and U4. This is for what?
I4, U4.
This is Q7, Q8, and R13. I4.
This is neutral, but usually we don't connect it for the voltage.
Neutral L4.
No, it's neutral voltage. The U4
Yes.
is neutral voltage.
And I4.
I4 is the neutral.
I4 is neutral.
Residual.
I4 we've connected I4.
For residual current.
Residual current, but sometimes it comes from separate CT. If it is CBC 100 and it's protected, it's protecting overhead line, so we'll use a CBCT. We'll connect I4 to separate CT, and the rest of the CTs will be of star connection. But we don't have it always, the CBCT, so we'll connect along with it the neutral from the 3 CTs. The auxiliary supply of the relay is in K card, and it's 110 volt DC, and nowadays relays accept AC also. Input and output. I could configure any one of the binary output to the trip and to the start or whatever signal I want from the relay. So we've connected binary output 4 to the, I presume, no, sorry, it was like 4 and 5 basically, but we can open it from the configuration of the relay. 4 and 5. We'll check it from the relay. Now,
That is the trip signal.
trip signal, and we route one other signal, just the pickup before the trip. Once it starts counting
Like alarming signal.
alarming, and to see the sensitivity of the the setting is in on. For example, in overcurrent the setting is in current, so it's 400 ampere. I wanted to see whether it starts counting once it reaches 400 ampere or not. Maybe it's delayed. So that's, we call it the pickup, and usually we'll take it just for the feedback in the test kit, so to check the sensitivity of the setting. I'll go through the relay first, communication. Once the relay is on, I can communicate with it through different software. Each manufacturer will have its own software. For example, here for Siemens we have DIGC4, and for new Seimens Relay, which is available there we have DIGC5. This series they call it separating 4, there they call it separating 5. It's just different manufacturing, but each relay type, for example, all Seimens Relay usually will have 1 or 2 softwares, and ABD, and we have still also different softwares. Now I have the software DIGC4, which is for the relay. I will communicate with the relay first. Storage open. But the communication usually goes through a serial port or even USB port. We have it here in the front. We could have other ports in the back. I've connected this wire to the laptop. Now I have opened the setting of 7SD5. Here it's appearing the full ordering or at least half ordering for 7SD522. Again, each number will decide some feature in the relay. This is the setting. First of all, this is online, so I'm already communicating with the relay. I hope it's clear, and I cannot see the communication. But here at least we can see this is online now. I'm communicating with the relay, and I have the setting. I have device configuration where I can enable or disable any function of the relay. For example, I have differential protection enabled. I have distance, or we call phase distance. What is the characteristic of the relay here? Quadrant. We could have more characteristic or even some other. We always use quad nowadays for the phase and for the distance. For the phase and for the air. I could have overcurrent or any other function enabled here. Here I can change it always, depending on whatever I want to enable. I have the masking. The masking is configuration of the input, output, LED in the relay, and whatever, say, external signals goes out from the relay. Now, I want to check only one thing here, which is the pickup and trip, which I've taken it as feedback to the testing kit. So, go to the binary output. You want to know which output I have configured. So, I have distance pickup in binary output 3 because I make it high here, and I have the trip in binary output basically number 4. I have the distance protection general trip in binary output 4. Once I know those two wires, I could take feedback from the relay to the testing kit. Originally, this trip would go to the circuit breaker, but here we take it to the test kit for the testing purpose. CFC is like configurable functions. We usually don't use it. I have the power system data. So it's 33 kV, and the secondary voltage. What is the secondary rated voltage here? 110 voltage. Is it AC or DC in this case? AC. Because assuming this is coming from the BT, this is not auxiliary supply to operate the relay, it's for measurement. So whatever in the primary 33, I'll get it in the secondary as 110 voltage. The CT, primary is 400 and secondary, so the secondary rated current is 1 ampere, the rated voltage is 110 and secondary wise. And here I have the setting of the distance relay, so I'll go through the setting and whatever differential or any other relay that is enabled. For example, distance relay, I have zone 1 setting, and in the table you need to decide the distance relay characteristic. What was the characteristic which we selected already from the beginning? Quad. And we have 3 types or 4 types of setting. We have basically the relay work in ohms. So we have for the impedance either reactance or resistance. So we'll have the same reactance setting for phase and air, but the resistance setting will be different from phase to air. So here, first one is resistance phase to phase, which is 19.8. For which zone? Zone 1. We're in zone 1. The reactance setting is 2.38. 2.38. You need to record this because later, once we are checking the relay, we need to compare the setting with whatever is coming in the test kit.
Please record these values, please. Is it in secondary ohms?
I presume yes.
Yes.
This is secondary. Resistance for phase barrier 26.3. This is zone 1. Zone 1B usually we don't use it, but it's used to cover the whole line. Assuming zone 1 usually we, as per MEDC policy, and usually globally it goes to up to 80-85% of the line impedance. What is the timing for zone 1? It's 0 seconds, so it's waiting no time. The second zone, which is zone 2. Again, the resistance reach for phase and air for zone 1 and zone 2 will make it the same. But the reactance is different. The reactance reach is 5.62 for zone 2. This is zone 2 now. We are here in zone 2.
5.62.
5.62. Reactance reach. Resistance reach both same as zone 1. The time. What is the timing for zone 2? Means 400 milliseconds. Zone 3. Usually zone 3, assuming this relay is in the 33 kV side of the sending end of the line, zone 3 could have reached to cover the 11 kV of the substation. So the impedance here is quite high relatively. But anyhow, for testing purpose, I've reduced it a little bit. So the resistance for phase fault is 22.1. The reactance is 8 ohm. And the resistance for phase to air is 30.2. And the time? 1 second, 0.2, which is very, very high in terms of protection. But because this is a very backup protection for very far away substations, like reaching from the relaying point several kilometers, plus it goes to transformer and bus bar and other loads. So now we've got all the data we need. We can go through the test. I don't need the relay software for the testing. I always need it to download whatever I want from the relay, or to make change here and send it to the relay. But the testing software will be different. But I'm gonna use it today for the measurement at least. So I will start the measurement, and you will record the whatever we are injecting and whatever you expect in the primary, thus you will see it in the relay, and where it's coming, either red, yellow, blue, or neutral. You will record from here. Currently, I'm not injecting anything. I hope it's clear. I'm not injecting anything, so it's 0 ampere and 0 voltage. And we have also the positive, negative, and 0 sequence. We'll start injecting. I already started injecting 110 voltage to operate the relay. So the relay is on now. After the auxiliary supply from the Omicron, I'll go through the test. Usually, what happens in all days, we will just inject certain value as per whatever we think it's right for the relay, because all test kits will not have such a software. Now the new software, which is Omicron, have the ability to import the setting from the relay and upload it to the test kit. So whatever setting we saw there, we could see it here again in the Omicron software, which is nothing to do with the relay anymore. Here I have already imported the testing, the setting, and I could even check it. For example, we have distance, zone 1. I should have same values as in the relay, otherwise the test result will be wrong. So for example, zone 1, you can see 19.8 for phase resistance and 2.38 for the reactance, to 26.3 for the air resistance, and the timing is 0. The same goes for all different settings in the relay. So this I have imported it from the relay. I've exported the setting from relay to my computer, then take it back from there. Now the Omicron also have the ability to show you the characteristic of the relay. So zone 1 cover is highlighted here, and zone 2 is highlighted here, and zone 3.
Maximum 2%.
This is the highest. So now here only the setting. I haven't started any testing yet, but at least now I can confirm whatever I imported from the relay is exactly same as the setting in the relay. Otherwise, while we are testing, it will give us wrong results. So we'll start the testing. We have 3 types again of the test. I want to check the measurement to make sure that the relay CT and VT connection and setting is correct. So first I'll check the measurement. The second one is the timing. I have 0 second for zone 1 and 400 milliseconds zone 2 and 1.2 for zone 3. I have to check whether it's really operating in like 0 second, otherwise it will take some time a little bit. And the same goes for zone 2 and zone 3. Usually during annual maintenance we'll only do measurement and maybe timing, which also call it shot test, because I just want one shot and I'll take the feedback from it. And search test. Usually search test will be done maybe at the beginning. Once I'm changing the setting, I want to make sure that my setting is correct. Basically, search test is testing the reach of the relay. We've made some setting for reactance and resistance, and we want to make sure whether it's exactly reaching this impedance or not. I'll start with the measurement first. These files we've already made, otherwise it needs some configuration to whatever measurement you want to make, what current you want to inject, and plus I'll go through the timing and other tests later on. Again, the Omicron will give us some ready-made, what we call it, template for the testing, which is very, very useful. I'll start the testing. In the tables, you could record only the normal measurement, which is first injection in 63.5 volts. I'll start it, then you can read from the relay. So we're starting the test. Now I am injecting a current and voltage. Is it readable?
Yes.
So, what we are injecting? Are we injecting really 400 ampere?
No.
How much we injected? 1 ampere. But the CT setting is 400 to 1, so it's appearing like 400 in the relay. And the voltage?
19.
And what we are injecting?
100.
Less, 63. 110 over square root of 3. Phase voltage. Now, one more thing that you should check, that we inject in red phase. We have both current and voltage, so we have 0 in the other yellow and blue. We good?
Yeah, students ask, is this from the secondary side? But it was read from the secondary side, and it appears like as if it's in the primary. So it means that the relay shows that the reading should be in the primary 400, but it receives just 1 ampere because of the ratio. So it just converts through the software that show you that maybe in the primary it's 400. Actually, in the secondary of the relay, you cannot inject 400 here. It's just 1 ampere. The same thing for the voltage from the secondary of the VT.
We injected only 1 ampere, but because the CT setting is 400 to 1, we can read it in the relay, either 1 secondary or 400 ampere primary. Again, during testing, you should know that you're injecting in the red phase, you should not get any reading in the yellow and blue phases. We'll go to the next test. Now from here you can see that we are injecting in which phase? Yellow phase. And the same goes for the current. We're not injecting anything in red and blue. Now we'll inject in the blue phase. Again, in the relay, it shows the blue phase of 400 ampere, and the same goes for the voltage. Now this is for like normal injection. I could be injecting some current that I wanted to see in the sequence elements, positive, negative, and zero sequence. Before that, I'm injecting different values, and like unbalanced values in all three phases. So what's appearing in the relay is 400 because we've injected 1 ampere in the red. Here we are injecting this one now, number 4. I'm injecting 63.5 voltage in the red and 40 in the
Maybe they have some confused now.
and 20 in the.
عادي كان ناس كانت
Student ask, is this measured quantities here or injected?
It's injected from the test kit and measured in the relay. Now I'm showing you in the Omicron whatever I have injected. I've injected 63.5 volt and 40 volt in the yellow phase and 20 volt in the blue phase. Now I want to check the relay. I'm assuming that I could be looking at the screen here and reading from it, or because I have already communicated with the relay and I have online communication, whatever appearing here is from the relay now.
You can have a
Through USB.
relay if you would like.
افتح رحمة الميجرمنت at least for one.
already on the measurement imbalance now.
What is the red phase? At least voltage.
Now here we have, if you can see, the imbalance reading: red, yellow, blue, and neutral. 400, 300, 200, and imbalance 173 ampere.
So,
That what
shows
it
here that
shows.
If you have unbalance, so you will have positive, negative, and zero sequence components. Which are given here. Current is different here. Muhammad, the currents are different because we have different current in phase A, different from B and C.
Different frequencies.
So you have this.
Local chapters, the sequence is 1 0.
We'll go through positive and negative also. In the next test, I will inject only positive sequence because it's balanced. So I'm not expecting any negative sequence or zero sequence. This is 63.5 voltage with degree 0, and then the same magnitude with minus 120 and same magnitude with 120, and all 1 ampere also with balanced energy. So am I during test number 5 expecting any negative or zero sequence? There should be none. So I could be reading from the relay, or because I'm communicating with it, this is from the relay. Whatever appear here is from the relay. Now you can see it's 400 ampere, which is basically 1 ampere in the injection, in all 3 phases. So zero sequence in the current is should be zero. Yes, zero sequence is 0. Positive sequence is 400 ampere because I'm only injecting positive sequence, balanced current, and negative sequence again also 0. The same goes for the voltage. Now the next one is negative sequence. I couldn't open it, otherwise I have to stop the test. But we can see it from here.
How to test it?
That's
Different.
values.
negative sequence.
Yes.
Right now.
For this one.
We can disconnect one of the faces.
Oh, now it's negative sequence. What I have did in the Omicron only, I've changed the angles. Otherwise, it's still the balance injection. Same as positive, but I've changed two angles from 120 to minus 120, and the same for the
Can you
yellow
show
face.
can you show us one?
The injected.
I'll go through zero sequence, then once the test is finished, then I can go through it. Otherwise, now I have to start the injection. I didn't finish.
عادي عادي.
Okay, we are here. This is the negative sequence. What we changed from here only the angle. It was minus 120, now it's 120. And the same goes for the blue face. It was 120, now it's minus 120. The same for the current also. We've reversed it only. لما نكمل عبد الله اللي كان البداية ولا إيش؟
عادي خلنا نعمل next. شوية سحبه عشان تخلص. الحين نكتب. أيوة الحين نكتب.
We'll go to the last one in the measurement, which is zero sequence. We are injecting again same values but with same angle, basically zero angle. So what we are expecting in the zero sequence is the summation of all phases. Now we can see it in the testing here. We've injected same values with angle zero. So it's giving me zero sequence.
هذا
So this is the measurement. All I want is from this only to know whether whatever I'm injecting from the testing kit is received correctly in the relay. Up to now we haven't tested the distance function. Now we'll go through the distance function. I'll close this test. If we've continued it all without stopping, it will show me like a green mark for it's like test either pass or fail. But we'll do it for the timing at least. Now I have two tests. I want to check the reach of the distance relay in each zone, and I also want to check the time. First we'll start with the timing test.
This is the set.
It's an Omicron cold shot test.
This is a software of Omicron test set that can be applied for any relay. Just extract the data from the relay, then put it here, then they will check each zone separately. The test set will inject the currents to the relay and respond, receive the signal.
نفسك اللي يسويها هذا So that is
This is both of
so it can be used. Huh?
how they do it. How they do it.
Yes. Yes, this is that is digital. Interesting. القيم اللي اختاروها فور زيرو سيكونس راندوم ولا يكون
For 0 sequence.
في النيجاتيف ما اعطانا different values for current.
Unbalance.
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 أنا فتحت
النيجاتيف سيكونس غير الانجل خلاها نفس الغير الزيرو سيكونس خلاها نفس الانجل وقت 0 0 ولا 1 1
We continue?
Yes.
We'll go to last element. We'll skip the search test for now, then we'll come back to it. So we are in the timing test. I want to check the time. Basically what I should be doing is that I could select some random point and inject impedance. This will inject the impedance, whatever I have selected here. Basically it will fix the current and change the voltage based on whatever value I want. I've selected some point here already in zone 1. So this is can be seen. I have here zone 1 and zone 2 and zone 3. I've selected these points for the testing. What I'm expecting is the trip signal. So I'll start. I'll inject the first one. It will continue the injection, but basically we can see the time.
What's the time of the first
We'll go through details when it's complete. For example, I have line, I could be injecting any type of volt, whatever I want. So I have here first one is line to air. I've selected some point in the zones. This zone is drawn based on the setting which I have already imported. So this is the setting, the characteristic of my relay. I have chosen 3 points in the line. I could be choosing anywhere inside the zone. So first one is in zone 1. This is the one. I'm expecting trip in which time? 0. Let's say the timing here. The time supposed to be 0. What is the actual time? 400. Sorry, T actual. We're looking at T actual. 58 milliseconds. Again, when we are saying 0, it's nothing like in 0 seconds. So basically the relay will take at least 30 to 40 milliseconds. Even in real life, we could be finding the relay operated in like 30 or 40 milliseconds, but again, circuit breaker will take its own time, which normally 60 to 100 milliseconds. For the whole tripping, it will go like 150 milliseconds.
Muhammad, the algorithm is here FFT. It takes full cycle. So it takes full cycle for measurement of the amplitude of the signal, taking the Fourier transform, and after 40 milliseconds, it will decide.
It will decide.
So this is why we have 58 milliseconds. It takes 2 cycles to decide if it's a fault or not, and then send the signal. So the signal also takes also the output contact of the relay.
So now,
One side. Yes. So 2 sides.
it doesn't matter. طالما اني انا I have taken it. احنا في last test. نحتاج نتأكد
Muhammad,
It's 2.6.
just one question.
Yes.
We have the previous one, minimum and maximum. It means this is the range of your zone 1, the range of the operating time.
It's the range, but basically at least what I understand that if it goes beyond the maximum, then it will give me failure in the test. This is changeable.
Yes.
I could be changing this basically. It's the same goes for the T-min and T-max.
So it means that well, we have the line, this is the line, and we have our substation here, okay? And we are protecting, this is the next substation, you are protecting, for example, 80% of the line. If the fault here in this region, means that zone 1 should operate. If it's in the next substation, this is zone 2, and inside zone 2, the fault inside zone 2, it should operate. Then this for zone 3. So when he just click here or put the point here, the relay itself will inject some kind of current and try to reduce the voltage to see the under impedance part, so that the impedance will go direct to this point. And then it will measure the operating time.
Is the time for the tripping is different as we go far for the zone to zone?
Zone 1, which is this one, will only cover like 80% of the line. If the fault beyond 85 of the line, then usually what is happening that I don't want really to trip if the fault, let's say, after lines we have transformer. Transformer has its own protection. We have differential transformer protection and we have overcurrent and whatever protection in that substation. I'm protecting basically the line for the distance relay. So zone 1, 85 of the line, percentage of the line impedance, because I'm sure the fault is in the line. That's why I'm tripping in no time, like 0 millisecond. But zone 2 and zone 3, it goes beyond the line. It usually for zone 2 will cover like a little bit, like 120% of the line. So I need to give some time to whatever protection inside that remote substation to operate. So I'm giving it for 100 milliseconds.
So this is backup now.
Will pick up.
Zone 2 will be backup, but zone 1 is main. Whenever zone 1 is enabled, it's main.
No, but the relay in the zone 1 is backup for the relay in the zone 2.
The relay is at one place, relaying point in the 33 kV side of in the grid station, called grid station, where we have 33 kV voltage. Alright? So the relay at relaying point, only at one point. It operates in different characteristics. Zone 1, zone 2, zone 3. It's reaching different places in the line. This is the benefit of distance relay, that I could be enabled different setting with different times. So, assume this is the line. You can see this one. This is my line. This up to here, you can see this, the end of the line. This is the end of my line. Beyond this is no more in the overhead line or whatever I'm protecting. It's in the substation, remote substation. So up to here, I'm covering the line for zone 1 and a little bit of zone 2. Zone 1, basically the whole zone 1 is inside the line. So I'm sure if it tripped on zone 1, for 100% sure the fault is in the line. But if it tripped in zone 2, it could be at the end of the line or in the remote substation. I cannot be sure in this case. Up to this line, it's 100% of the line. So zone 2 covering a little bit of the line and extended to whatever needs the line. It could be another line, it could be, usually we have transformers.
But if we have another line, it should be there is another relay.
Yes, but again, zone 2 could be enabled to protect only like the first 20% of that line.
But about the second relay, it will consider it in the zone 1?
Forward only. Yes, it will consider it in zone 1, but it will not see in the back.
What about the timing will be considered for the zone 1 or about the backup?
Basically, in this case, 400 milliseconds given so that it will give time to particular relay in that line. That's why I've given 400 milliseconds. Otherwise, could put it 0 if I'm sure the fault is in the line. But when I am ever sure that the fault is in the line, I have put the time for zone 1 as 0 millisecond. The same goes if there is differential, which is unit protection. The timing is 0 always, because I'm sure it's in the particular unit.
So,
Now,
so this one is backup for the differential.
Zone 1 is backup for the differential. Basically, the line, if it is cable,
differential is protecting only the line. So zone 1 is backup for differential. If you have differential line, he will show it on the up there.
I could explain it here. I have 33 kV bus bar. Alright? This is a remote station by itself. And I have here another substation where I have transformer and 11 kV bus bar. This is 11 kV. If I have a line from here until this substation, here I have circuit breaker, here I have circuit breaker. This line is like 10 kilometer overhead line. What we are having is this transformer is 33 to 11 kV. Basically we have a 20 MVA, but it doesn't matter now. I have the relay here. I have this relay here. Basically, if we have cable, we would have a fiber optic here and a CT here, and it will go through fiber optic from relays. This is a differential protection, 87, basically. But we don't use, if we have overhead line, it's difficult to put fiber optic. The fiber optic goes along with the cable. This relay is basically differential. But if I'm not having fiber optic communication between substation, let's call it 1, and substation 2, then differential is disabled. What is the backup in this case? Distance, basically. I could be, if I'm sure that it's only overhead line, I should have put from the beginning only distance relay. I don't need the differential. But at least this is what was available in the office maintenance substation. So, now assuming we have a distance relay. The setting of distance relay is in ohms. I have 10 kilometer. Can I calculate the impedance of the line? I have the data of the overhead line. I could be calculating the impedance of the line. I will enable distance relay here. And zone 1 is only reaching up to 80% of the line. Assuming the line is like 10 ohm. 80%, the setting of zone 1 should go like 8 ohm. Whenever there is fault inside this zone, definitely it will be in the line. So my timing here is 0 millisecond. But I cannot go up to here because the precisely reading is difficult. So if I extended zone 1 with 0 tripping up to here, the fault could be at least here, and it will trip the whole line. I have to search the whole line in this case to find the fault, and the fault is in this substation. So zone 1 only up to 80 or 85% of the line. Now I have zone 2, I'll extend it a little bit to reach at least, let's say, the 33 kV side of this substation, or at least half the transformer impedance.
After 120%.
Exactly, 120% of the line. When I'm saying 100% of the line, it's this. If I extend it 20%, it goes up to here a little bit. Now, if the fault is here, which zone will trip? If 1 didn't trip, 2 will trip. But basically, it's not backup for zone 1. It's not backup for zone 1. Zone 1, if zone 1 didn't operate, definitely zone 2 will not operate. Means the relay faulty or some issue with it. But if the fault here, the fast zone will be zone 1. It will trip. That's why I selected one point in zone 1 and I've checked the tripping. Now, zone 2, usually I have here some protection, which is basically overcurrent earth fault. And I have transformer unit protection, 87T. I've given zone 2 400 milliseconds to wait for this overcurrent relay. This should trip if the fault here at this point. If they didn't trip, then zone 2 will trip. And the engineer, once he's searching if it is tripped in zone 2, he should start from here, assuming that the fault probably will be at this area. Because if it is here, zone 1 will operate. 120%. Now the last one is zone 3. I'm giving very high setting for zone 3. It will extend it up to 11 kV substation. But what was the timing for zone 3? 1.2, very, very high time. In protection, we are talking about 200 to normally 300 milliseconds, even in backup protection. 1 second or 1.2 is very, very high time. I've given it because it's backup for multi-relays. Assuming the fault is here in the element, I have overcurrent relay in the outgoing feeder. If I have bus section, I have another overcurrent relay. I have the incomer, transformer incomer protection. So basically, I don't expect zone 2 to operate except in one case. Whenever the whole protection system is off in this substation. At this case, only zone 3 it will operate. And this is what happened. Usually, we lose the whole auxiliary supply, so all relays will be off. Nothing will work in this substation. The backup is zone 1. So, sorry, zone 3. The backup is zone 3.
So after 240?
After 1.2 seconds.
No, about the percentage.
We didn't go in percentage in each one. It could be 240, but basically what I'm doing while doing the setting, this is the line setting, which is 80%. Zone 2, I could go with 120 of the line. Zone 3, I will include the transformer impedance.
So in this case, for if there is another substation after the line, in case we have another line.
In case we have here, sometimes we have here 33 kV bus bar and it's gone and another substation. Zone 1 and zone 2 will be the same basically. Zone 3 will be based on the next line. But in this case, usually if I'm considering this line and transformer impedance will be higher. So I'll go with the transformer also. If I set it like to cover, for example, even 80% of this line, probably it will trip and fault in the line and in the transformer. And I don't want that. I wanted to increase the setting of zone 3. I wanted it to go further but not to trip in the load. That's my concern in zone 3. Yes. It should not operate on the load. Plus for this we have something called load encroachment. So if it goes in the load area, it will not trip. But basically in this case, even the load area is shown here, by the way.
But we can proceed in the testing because
then one last step. But this is the load area. If I'm here,
load encroachment area.
So, to conclude this test, we've got assuming it's supposed to be 0 setting for 0 second for zone 1, we've got 58 milliseconds. Zone 2, assuming it's supposed to be 400 milliseconds, it got 442 milliseconds, 0.7. And zone 3, 1.246 seconds. And it was supposed to be 1.2, basically. 1.246. Last test. Here all I want is to make sure that it's sensitive enough. So, my setting is at this particular line, but the relay maybe goes a little bit higher or lower in terms of impedance. So, I'll do this test and I will test the reactance and the resistance. It will go. Second. Search test. We are in the search test. Now here I have one limitation, that the setting is fixed to 2 ampere and the test kit is changing only the voltage. So it's basically will not be able to inject high impedance. So zone 3 will not be able to test it. We'll test zone 1 and zone 2 during the search test only. We'll start. Now in this line, do you see this line? I'm expecting the resistance setting to check it. And the next one will be this line, and here I'm expecting the reactance. All good? We'll start it. The result will show it later. This one will not show the result. But this is line to earth, so basically this is the earth resistance. This a little bit will take some, like a minute, because it starts trying some multi-points to get it right. It will inject a little bit before the line, and it will go slower, slower, slower to reach the line.
Automatically.
See where is the exact number.
This is an automatic operation.
Automatic operation. I only have to select the line where I want to inject only.
Very
And I've
simple.
already selected this line in 90 degrees 0, 0. So it's basically here and here. Again, here the feedback is the pickup. I don't want it that I don't want to wait like 400 milliseconds or 1.2 seconds for zone 1, zone 2, and zone 3. Or all I want to relay to identify that a particular fault is basically in either zone 1 or zone 2. Now line to line. I want to get from line to line only this one, the resistance, because it's for phase and earth is different. For timing, only this one will do it once, so you could be recording in two-fold time. Line to earth first one, then line to line in second table. One table will skip. Now the test pass will just see the result, so you can record the result. What was the first fault? Line to earth. Now the actual, what you want, you already have your setting, you want only the actual. What was the resistance? First test, am I expecting the resistance for phase fault? No, it's earth. So basically it's 26. What was the resistance? For zone 1, zone 2 the same, by the way, the resistance. What was the setting?
26.3.
What is the relay pickup? 26.42. Almost the same. And the reactance, it was 2.38, now it's 2.39. This is the actual, what relay will operate based on. Zone 2, reactance, 5.648. Zone 3 will skip it. Again, you're comparing with your setting. You already recorded the setting. You only take from here the actual measurement, which of the actual relay characteristic. For the phase, it's supposed to work in 19.8. It worked in 19.8.
No.
9. And the reactance basically the same, but again, see you have a little bit different result. 2.4 for zone 1 and 5.64 for zone 2. Here I want to see the sensitivity of the setting only. Assuming I could have here like in the setting 20 ohm, but it operated in 19, or I have 25 ohm, it's operated earlier means, or later, if the impedance is later. So, to summarize this, we've done measurement test, timing test to check the time, and search test to check the reach of the relay. If you have any question, please.
You can set the time delay to another,
I can change the time.
and you can put it the same. So there's
Whatever I change here, I could take it and put it in the test kit. I can change anything I want in the relay in terms of setting, means reach and time. I could go to zone 2 with some time delay, zone 1 with some time delay. It's configurable.
But in the relay itself, it's not depending on the distance. It will trip in the same time if you
On
want.
whatever, yes, the time will depend on the zone, whichever zone is covered in the fault. If the fault in the line, it will trip in 0 seconds because it will see it in zone 1. So this basically, whatever you put in the setting, it will act based on it.
But you can cover whatever you want at the same time.
Only during,
in,
yes,
in
but
the zero time.
yes. But everything you do it during setting. Setting is very, very important. Once you've done your setting, if it's operated wrong, mostly it will be because of the setting, not the relay. Relay maloperation is very, very less. Yes, please.
In case you have
Yes.
there is another relay here.
Great.
We have zone 3, for example, it's reached until here.
Zone 3 will go very, very far.
For example, zone
But,
2.
okay, zone 2 will reach. Yes.
And here is zone 1
Yes.
for this relay.
Great.
Zone 2 will be backup for zone 1 here.
Basically, yes. But what time zone 1 will not operate? Only if the relay is faulty. Zone 2 will operate.
So it will be backup in this case.
The nearest relay to the fault should operate. It's always all-time protection. The nearest relay should operate. If not, then the backup.
يعني الزون 1 هو المين ريلي باقي كلهم باكر يعتبرون حاجه
Exactly, backup. Zone 1 is the main relay. It's one relay, again, multifunction, but zone 1, which I'm expecting as main protection. The rest is backup. Plus I have overcurrent backup.
هل مثلا في الريلي الثاني يعتبر باك اب في الفانكشن اللي فيه مثلا عشان يلقط التراب يكون اكثر ولا يخلي نفس الفانكشن في الريلي 1؟
No, basically if I am having distance relay as main protection, I will have another relay overcurrent one.
اوفر كرنت ما تقدر تسوي
I could be, but again, the cost for the relay, if it is having distance relay and differential, would be higher than normal overcurrent relay. It's cost-wise, it's nonsense. But then, like in video, they would have two relays, both main, the same. In high voltage, they have two relays also. But it depends. We have distribution at there.
زين هذا differential relay.
هذه basically differential وفيها distance فيها overcurrent
لكن
multifunction.
لكن بغيت استخدم differential as a distance I have to have
If I want differential for line, I need communication between sending and receiving end of the line, and I need two relays.
but the distance relay
Only one relay, you don't need communication. It's nothing to do here. It will not trip breaker, will not make reading, anything. It's only take reading from this point. Only differential need communication.
differential distance أغلى من differential.
No, differential is costly. Not the relay, because it will not be the relay, it will be two relays. Differential, two relays, communicating with each other.
عشان كذا تبغى الفايبر
One inter, yes,
Fiber optic.
exactly.
يعني يكلفك في الريد relay يكلفك fiber optic.
But it's worth it to save the line. Plus you will make sure that the fault is in the line.
ممكن تستخدموا هذا differential.
Depend. If we have communication, we'll put differential. If we don't have the communication, then we'll use distance.
وهل مثلا اذا استوى عندكم الفولت في اللاين تقدر تحدد
مسافة.
هو
Exactly.
ياخذ لك ولا في
It needs some setting. It's called fault indicator. It will give. Not bad.
لكن انا
But at least you could be. هي بالأم وأنت تحسب 50% من اللاين كذا. But